Okay, let's do a few examples. Okay, so let's say we have w to the power of 7 divided by w to the power of 5. Okay, this becomes w to the power 7 minus 5, which is w to the power 2. And you can imagine if I had 7 w's and 5 w's, I would cancel 5 in the top with 5 at the bottom, and I would have 2 in the top left. Okay, that's that. Okay, how about something like 2 to the power of 4 over 2 to the power of 7. Now, if we just use this, that we have our base, we take the numerator, that's important, we take 4 minus 7. 4 minus 7 gives me 2 to the power of negative 3. Now, we know how to do this. This means it's 1, because there's a 1 in front, 1 divided, because it's negative exponent, 2 to the power of 3. And this is 1 over 8. Okay, that's one way in which you could have done it. Or the other way you could have done it is just by, in your mind, seeing, well, there's more factors in the denominator than in the numerator. Since there's 4 in the numerator and 7 in the denominator, 4 of the ones at the top will cancel with the ones at the bottom. So in other words, from the very beginning, we could have seen that all of the ones at the top would cancel, so we're left with the one factor, which is in front here. Okay, and how many would be left in the bottom? Well, 7 minus 4. Okay, that's what we had here. Higher, that's what we had there. Okay, the denominator's exponent minus the numerator's exponent, but then I must leave my answer in the denominator. So this is 2 to the power of 3, and you can see we saved a few steps there so that we could immediately go 1 over 8. Okay, now a little tip, choose the side with the highest exponent. If I say side, I mean top or bottom, highest exponent. That way you just never have negative exponents, and then you just subtract, then subtract the other exponent. Okay, actually the other side's exponent. I'm running out of space here. Okay, I'm sure that makes sense to you. Make a note of this, and then it's actually quite simple. Whatever you have, let's say we had, let's do one more example actually, where we can combine some things. Okay, let's say we have 2 to the power of 4 times 3 to the power of 7 times 2 to the power of negative 1, all divided by 3 to the power of let's say 6, and 2 to the power of negative 5. Okay, that's maybe a bit much. Let's make it negative 3. Cool. Now, the way I like to do it when I've got a bunch of things here, and here you can see here too, we have bases that's being multiplied together, and we have bases that's being divided. So the way I like to do it is just writing out all of my bases. There's my 2 and there's my 3. That's all of the bases that I have. Then I add up everything in the numerator and I subtract everything in the denominator. So I've got 4 minus 1. That gives me, so here the exponent is 4 minus 1. And now be very, very careful. This was a trick. In the denominator, I already have negative 3. So it is minus 3. And that will become a positive. Okay. Pause the video here if you didn't get that exactly, but this is very important. When I subtract a negative, it becomes a positive. So I must subtract the negatives, the denominator's exponent. Okay, and in this case, it will make that negative a positive. Okay, so the 3's exponents are 7 minus 6. So 3 is very easy. 7 minus 6, and this time you can see this is just 6. So when I have 7 in the numerator and I subtract the 6 in the denominator, it's just simply 7 minus 6. So here's what I have in the end. I've got 4 minus 1 is 3, minus minus becomes plus 3. That gives me 2 to the power of 6 times 3 to the power of 1. 7 minus 6. 2 to the power of 6, I think, is 64, times 3 to the power of 1 is just 3. So 64 times 3 is 180, 192. 192. That is the answer for this expression. Now, another way in which you could have done it is you could have just said, okay, well, let me do the top, simplify the numerator perfectly and the denominator. And one other thing that you may do is any negative exponents may go to the may change sides and become positive. So this can become 2 to the power of 4 times 3 to the power of 7 times 2 to the power of 3, and the 2 to the power of negative 1 can go to the denominator as 2 to the power of positive 1 times 3 to the power of 6. This is probably a safer method, just to get all of my exponents first as positive numbers. Now, one very important thing. Remember, you can only apply this when you are working with single terms in the numerator, single terms in the denominator. In other words, if there was a plus or a minus so that there's more than one term, you couldn't use this. You would have to factorize first, and we'll look at examples like that soon. Okay, so then what we do is we can take this to the numerator. We've already done that. Now we can simplify one more step. 2 to the power of 4, 2 to the power of 3 gives me 2 to the power of 7. So I'm adding the exponents, times 3 to the power of 7 divided by 2 to the power of 1 times 3 to the power of 6. And now I can go and say, well, now it's 2 to the power 7 minus 1, so that's 6, and 7 minus 6, that's 1. And then this will simplify exactly. That's exactly what I had there. So that's also 192. Okay, I hope this makes sense to you. Let me do then one where I gave you an example. So let's say we have 2 to the power 200 and 2010 minus 2 to the power 2009 divided by 2 to the power 2005 plus 2 to the power 2011. Okay, let's say this was what I had to simplify. Now you will notice that I do not have, I do have more than one term. So I can't just go and say, well, this is 2 to the power, and now I subtract those, and then I get my answer. You can't do that. These laws only apply when you have a single term in the numerator, single term in the denominator. So if I don't, I'll have to factorize first, and this is what I'm going to do. The way to factorize these is to do the opposite of these laws. So what I'll do is I'll choose the smallest number of the lot. This is 2005. So I'm going to say 2 to the power of 2010 is 2005 plus 5 minus, this is 2005 plus 4. Now if you don't know why I'm doing this, just give me one moment and you'll see where I'm going with this. 2 to the power 2005, I'll leave like that, and then 2 to the power 2011 is 2005 plus 6. Now what I do is I'll use the opposite of my first law. My first law said that if I have same bases, base n times base to the power of m, then I add the exponents. But that means I can go the opposite way around as well. If I have a sum in my exponents, I can break the base up into two bases, one with that exponent and one with the other exponent. Do you see? In this direction. And that's what I'm going to do. I'm going to say this is 2 to the power 2005 times 2 to the power 5 minus 2 to the power 2005 times 2 to the power 4 divided by 2 to the power 2005 is already as I wanted, plus 2 to the power 2005 times 2 to the power of 6. Do you see how I applied it? Now every term has a 2 to the power 2005. I have a common factor, and I can take out that common factor in the numerator, 2 to the power 2005, and I have 2 to the power of 5 minus 2 to the power of 4. Those are the two terms remaining. In the denominator, I've got 2 to the power 2005. Here, the only thing that's left is the 1 plus 2 to the power 2 to the power 6. And here, this is my answer. 2 to the power 5 is 32. So obviously, this cancels. 2 to the power 2005. All 2005 2's cancel with all 2005 2's there, so I'm left with only those two terms. This 2 to the power of 5 is 32, minus 2 to the power of 4 is 16, divided by 1 plus 2006, 1 plus 2 to the power of 6 is 1 plus 64. So my final answer is 16 in the numerator divided by 65, and I'm sure this can't simplify anymore. Okay, so you can see this, you could have tried with your calculator and it would be impossible because your calculator can't calculate large exponents like that. So you'll have to first apply your exponential laws to actually simplify this question. Well, I hope you enjoyed it. It was quite a challenging question, and I'll see you in the next video.